This is Algebra 6-1, Solving Systems on Graphing. So we've been talking about different types of graphs. Well, this one is going to be seeing if these graphs have an ordered pair that falls on the line. So we're going to tell whether the ordered pair is a solution to the given system. So let's say we have something like these two different equations. We have 2/5 x minus y equals 0. And then let's say our second equation is 3x minus y equals 13. Now, this whole time we've been really concentrating on putting things in slope-intercept form, which is y equals mx plus b, but you don't need to do that for these types of problems. But they do give us the coordinate points of 5, 2. Your x is 5, your y is 2. So all you're going to do is a swap out. You're going to swap out the x for 5. You're going to swap out the y for 2. If you get the answer that they have told you it should equal, then your solution is okay. But for this to be a true solution, 5, 2 must work for both equations. If it only works for one and not the other, then it's not a true solution. So let's get started. So I'm going to swap out that x for 5, and instead of y, I'm going to put 2. Now my overall answer should come out to 0, so I'm going to keep that in mind. 5 goes into 5, those cancel. 2 take away 2 gives me 0. 0 does equal 0, so this one checks. All right, let's try this one over here. So I'm going to do a swap out again. So 3 times 5 minus 2. And the answer I should get this time is 13. If I get 13, then this is a true solution. So this gives me 15, take away 2. That is 13, and 13 does equal 13. So yes, since they both checked, the way we write our correct answer is we say 5-2, or 5-2, not dash, is a solution. And that's what you would write in your answer column. Okay, let's try another one. On this one, I have x plus 3y equals 4. And then I'm going to have negative x plus y equals 2. And the ordered pair they want me to use this time is negative 2, 2. Okay, so doing my swap out, I'm going to put negative 2 plus 3 times 2. And the answer I need to get is 4. So this is negative 2 plus 6. 6 take away 2 is 4. I have more positive, so it's positive. 4 does equal 4. There it goes. That one checks. All right, let's see about the other one. All right, if the equation comes with a negative, you have to keep that one, which means now you have 2, including the negative from the coordinate point, plus 2 equals 2. A negative and a negative make a positive. 2 plus 2, okay, is 4. Now, what did we need it to equal? We needed it to equal 2. So this one did not work. And this is an example where one works and one doesn't. So we would write 2, negative 2, 2 is not a solution. Okay, let's do one more. Here we have 2x plus y equals 5. And negative 2x plus y equals 1. And the ordered pair I'm working with now is 1, 3. All right, so let's go ahead and plug those in. So we have 2 times 1 plus 3 equals 5. Okay, it needs to equal 5. This is our key number here. So 2 times 3 is 2. 2 plus 3 is 5, so this one checks. All right, let's do this one. I have negative 2 times 1 plus 3, and my magic number here is 1, needs to equal 1. So negative 2 times 1 is negative 2 plus 3. That is basically 3 take away 2, so 1 does equal 1. This one checks. So we would say 1, 3 is a solution. The minute one of these doesn't work, you don't need to work out the other one. It's automatically not a solution. So you don't need to worry about that. All right, now what if we have something where we don't have a full equation? It kind of looks a little different. Something where they write y equals x and y equals negative 2x minus 3. Now this time they're not giving us the coordinate points, if you notice. But do see here that they're telling us that y equals x. So every time you see a y, put an x and then solve for x. Once you find that point, then you plug in that value of x and find y. So what does that look like? Well, here we go. So I'm going to put in, instead of this y here, I'm going to put in this x. So I'm going to put x equals negative 2x minus 3. Okay, I'm going to add 2x to this side to combine my like terms. These cancel. 1x plus 2x equals 3x, which equals negative 3. Get that variable by itself. I'm going to divide by 3. The 3's cancel. X falls down. 3 goes into 3 one time. A negative and a positive equals a negative. So my x answer is negative 1. Now I need to find my y answer. Well, if y equals x, then obviously y is also negative 1, because it clearly says right here, if I put in negative 1 for x, then y would have to equal x. All right, and negative 1. All right, let's try this one. We have y equals negative 2x minus 1 and y equals x plus 5. All right, now again, both of these are easy to see that their y equals something. You can pick whichever quantity you want to use. I'm going to go ahead and pick this quantity to plug in just because it has less numbers. So I'm going to put this whole quantity in for this y in this first problem. So I'm going to swap out that y with x equals, or x plus 5 equals negative 2x minus 1. Combine your like terms. Since I'm moving across the equal sign, I need to use the opposite. Use the inverse operation here. So these cancel and I get negative 1 left on this side. Bring down my 5. X plus 2x gives me 3x. All right, again, combine like terms, moving this 5 over here. So the opposite of positive 5 is negative 5. My 5's cancel. And I get 3x equals negative 6, because if they have the same sign, we add and keep the sign. Now to get the x by itself, I'm going to divide by 3. Okay, the 3's cancel. 3 goes into 6 2 times. A negative and a positive equal a negative. So far, my first answer is negative 2. Now plug this value in to solve for y. I'm going to pick this second one here just because, again, it has the less numbers. So y equals, now instead of x, I'm going to put negative 2 plus 5. Y equals 5 minus 2 is 3. So my final answer and what goes in the answer column is right here, 2, 3. All right, let's try one more. All right, I hope that helps you on your homework.